So 2 different productivities for the different sub-items. And then you were to cost your estimate with the labor and equipment rates. Yeah, that's about it. Okay, so let's go through it here. So my first task that I have shown here was doing the anchors, so drilling and installing the anchors. So we need to calculate a few things first. So wall area was one of them. So 7 meters deep was the excavation. And then the question told you the size of the lot somewhere. Yeah, so the first bullet said commercial property 25 meters by 45 meters. So meaning you're excavating down that entire cube. So 25 meters long, 45 meters wide, 7 meters deep. So the wall area is 2 times 25 because there's 2 different 25-meter long walls, plus 2 times 45. So that perimeter of wall times the depth of 7 gives you your square meters of wall face. Now the number of anchors, I was flexible on this one. So there's different ways of calculating the number of anchors that are required. One way is considering all 4 walls as one continuous wall, which is what's shown here. So perimeter of 140, so that's 2 times 25 plus 2 times 45. So that's 140 meter overall wall length. And then do your anchor spacing from there to come up with 210 anchors. What most of you did was what I've kind of done on the side here. Most of you either had 204 anchors or 216 anchors. If you calculated those quantities, I don't believe I took marks off. I did not intend to. So the way that those quantities were calculated was you looked at each individual wall separately. So you did a 25 meter long wall, you divided by 2 meter anchor spacing to give you 12.5 anchors times 3 rows. So depending on how you rounded the 12.5, if you went down to 12 or if you went up to 13. So if you rounded down and you went through that calculation, you would have got 204 anchors. If you did that same calculation and rounded up, so rounding 12.5 up to 13 and rounding 22.5 up to 23, multiplied by 3 rows each, that would have given you 216 anchors. So like I say, as long as you got either 216, 204, or 210, I did not take marks off. Excuse me. So, so you've determined the number of anchors that you have. Coincidentally, if you look at the 204 and the 216, if you add those 2 together and divide by 2, so take the average of the 2 of those quantities, you get 210 anchors, which is what I have here. But anyway, like I say, any one of those 3 answers I would have accepted. So the next thing I did was calculate the volume of grout per anchor. So you were told that the core, so the sleeve was 64 millimeters diameter, and then the anchor inside was 45 diameter. Hang on 1 second. Note here. Yes, so 64 diameter core, 45 diameter anchor. So you were to calculate the volume that would fill the space between the anchor and the core. So the same process that we've done in the past. So what I've shown here is the diameter. So I calculate the area of the core first, then I subtract the area of the anchor. That's this calculation here. Then multiply by the anchor length in meters. Gives you so many cubic meters per anchor. So you should have got almost identical to this number. It should have been very close, 0.0065 cubic meters per anchor. So depending on how you rounded, you may have gotten slightly different numbers there. So if that's the volume per anchor, then you would multiply by the number of anchors. So I did that down here, depending on the number of anchors that you calculated. So multiplying them all by the 0.0065 gives you the total cubic meters of grout that you need. So the conversion into cubic feet, that doesn't change. The number of cubic feet in 1 cubic meter, there's no interpretation there. That's a solid number. So there's 35.3 cubic feet in 1 cubic meter. So you would have multiplied your total cubic meters of grout times this conversion to come up with a total cubic feet of grout that you needed. Again, depending on the number of anchors that you calculated from the previous step. Then to calculate number of bags of grout, you were told in the question, so I've got it right here, that a bag of grout will cover 0.5 cubic feet, or will fill 0.5 cubic feet. So basically what you're doing is dividing your number of cubic feet that you've calculated by 0.5, or multiplying by 2 gives you the same answer. So you're doubling these quantities to come up with the number of bags. Should have been right around 100, maybe slightly below. So bags. So then your productivity. So this relates to your crew cost. So again, depending on the number of anchors that you calculated, the question told you 2 hours per anchor. So depending on the number of anchors that you calculated, you would double it. So multiply by 2 to get the total hours for your anchoring crew. So 210 anchors is 420 crew hours. So we come down here a little further. So we've got grout bag. So I've got the 100. I've got the crew here. So you need the drill. A lot of you missed the grout plant. So you need a grout pump in order to pump the grout into the cores for the anchors. So there was a significant cost there that some of you missed. So drill, grout pump, you have the 1 driller and then the 2 laborers. So again, in the question it said you had a 3-person crew. So you had a driller plus the 2 laborers. So I've doubled the number of hours here for the labor. All the hourly rates were provided to you for the crew. The grout, you had to add PST. So you did $7 per bag times 1.07, which is $7.49 per bag. So that includes PST. There was 1 nut, anchor nut / washer assembly per anchor. So again, depending on the number of anchors that you calculated, you would have the same number of anchor nut / washer assemblies. Again, you would add your PST to that unit rate. So $35 times 1.07. And then the last thing to calculate for the anchors was the lineal feet of anchor rod that you needed to purchase. So again, it relates to the number of anchors that you calculated. So if you calculated 204 anchors, you multiply by 4 meters per anchor. and then convert to feet. So multiply by 3.2808 feet per meter, giving you these totals of feet, again, depending on the number of anchors that you calculated. Your unit price for your anchors was given to you as $12. Again, you needed to add PST, so multiply by 1.07. When you're estimating in the real world, the vast majority of your material supply quotes, I'd say 95% of them, will not have any taxes whatsoever included. So no PST as well as no GST. So you as the estimator have to add PST to all of your materials. Unless the quote specifically says includes PST, assume that it does not include PST. Or you can call the supplier and ask them if it's unclear. So of course, if you're purchasing hundreds of thousands of dollars of materials, that PST dollar amount adds up quickly. So you need to ensure that you're including PST. So if you extended all those, so with all your quantities here and your unit rates, you could extend those out to get all these dollar amounts. So again, depending on your total anchors that you calculated, your number should have been around 220,000, give or take a couple thousand. So part of the question was providing an anchor cost per lineal foot. So what I was looking for here was your calculated total dollars for your anchor costs, so this total here, divided by the total lineal feet of anchors that you have. That was the total unit cost that I was looking for. So for this example here, I would go this 222,000 divided by the total feet. So I was looking for approximately $80 per lineal foot. Anchor supply and install. So the other item was the shotcrete. So this one had, so we previously calculated the 980 square meters of wall area. So we previously calculated the 980. So the other quantity that we had to calculate was the volume of shotcrete. So in the question, you were told that you were going to spray on, I believe it said 50 millimeters. See if I can find that. Yes, your shotcrete team will install 15 square meters of wall every 2.5 hours at an average thickness of 50 millimeters. So you would calculate your cubic meters of shotcrete that you needed. It's your wall area, 980 square meters, times the thickness, so times 0.05. Again, you have to keep your units matching. You can't multiply square meters times millimeters. That doesn't work. You need to have consistent units. So meters times square meters is fine. That will give you cubic meters. So you should have had 49 cubic meters here. Assuming you calculated the 980 square meters of wall area correctly. So the next one was calculating your productivity, so how many hours the crew was going to work. So you had 980 square meters of wall area. The question told you the information for production. It was, so I wrote it out here, 2.5 hours per 15 square meters. So the way to calculate your total hours is your total wall area, 980 square meters. So divided by 15 square meters, and then multiply by 2.5 hours. So you would get 163 hours. Now this solution rounds up to the nearest whole shift. So it rounds up to 168. I was accepting 163. So we've got shotcrete volume. So the crew for your shotcrete, you needed your grout pump, so 163 or 68, either one's fine. And then you needed it was a 2-person crew for shotcreting. So 2 laborers here. I just doubled the number of hours. Unit rates. So the shotcrete, again, was given to you without PST included in it. So you had to add the PST. So $200 a cubic meter times 1.07 is $214 per cubic meter. And then lastly, the reinforcing mesh, again, $20 a square meter, multiplied by your PST, 1.07. So you would extend all those out. And here's your total for your shotcrete, approximately $62,000. And similar to the calculation above, I was looking for a total unit cost. So total dollars divided by your total area. So per square meter, so about $63 a square meter, and this one was $80 per lineal foot. So your total, and those calculations are down here, your summary total for this estimate, so the 2 subtotals added together was about $285,000. Again, that will fluctuate slightly depending on the number of anchors that you calculated. Okay, any questions on that one? Okay, so I'll close this. So next on our list was the PowerPoint for today's class. So out of town costs, it was called. So we'll bring that up. Okay, out of town. And then there's a summary. There's I think a 2-page summary on the last 2 slides. Kind of like an estimate summary, quick summary of everything that we've done up to today. So out of town premiums. So some of those premiums can include things like accommodations for your crew, meals for the crew, transport. Transport being 2 different things. So transport from the hotel or motel accommodation to the job site, as well as transport the crew flying home on some regular basis. So that varies from company to company, depending on the hours per week that you're working. Could be every 2 weeks, maybe every 3 weeks, something like that. Other premiums include premiums for labor, equipment, materials, subs, and supervision. We'll get into those in this PowerPoint, as well as premiums for general conditions and overhead. So out of town work, so the cost of working out of town can be dramatically different than working at home. So your task as the estimator is to identify all the associated premiums, things like room and board, to include in your estimates. So you need to evaluate if additional resources are required to maintain productivity on the job site. So for example, maybe you need to hire an on-site mechanic. So these costs could be included in your unit prices, so included in your tender items, or they may be a separate line item, maybe on the bottom of your estimate. Maybe you've included it in general conditions, so that the cost is spread through all your items. So this bullet here, blended rates may be required. So we'll look at doing a blended rate, how you would do that. And then consider an allowance if a project duration changes. So if you're thinking that the project is 10 weeks long, it might be worthwhile to consider adding in an extra number of weeks just for an allowance. Now, I wouldn't go overboard and do 4 weeks extra or 6 weeks extra. Maybe you do 1 week extra. I mean, it really depends on the size of the estimate, the dollar amount, the size of your crew, different things like that. But a 1 week or a 2 week or a 3 week overrun on an out-of-town estimate can really add a lot of cost to the project. Now, if that schedule overrun is not your fault, so not the contractor's fault, you should be able to be compensated by the owner. Again, that's contract law that we're not going to get into. So accommodations. So your project personnel will require accommodations. So personnel including the direct labor. So the people on site doing the actual physical labor, the work. People like your supervisor, people like management. Now they likely won't come up and stay on site, but they will take trips up to look at to oversee the project on maybe once a month or every 2 weeks or something like that. So that type of cost needs to be allowed for. Subs, how do they get to the job site? Are they local to the project, so they don't need flights? Or are they your subs from your hometown? Are you bringing them up there with you? So who pays for the subs to get to the job? As well as their accommodations there. So accommodation type, so those things can include things like a hotel or motel. So depending on the duration of the project, you may be able to establish a daily, a weekly, or a monthly rate. Typically, the longer the duration, the higher the rate that you want. So what I mean by that is, if you're there for 6 months, you want to establish a monthly rate with the motel or hotel. Typically, the monthly rate will be cheaper than the weekly rate, and the weekly rate will be cheaper than the daily. So meaning a monthly rate would be cheaper than a 4 times weekly rate, and a weekly rate would be cheaper than a 7 times daily rate, is what I mean by that. Rental units, that's kind of the same thing. Or is there a camp? Now camps are typically for fairly large projects, like the Site C Dam up in northern BC. Maybe there's a cost for camp, a daily rate for camp. Those things should be provided to you. If you're going into an already established camp, you would typically be told what the daily rate is for the camp. So must meet minimum standards, so regulations, union contract. So what that means is you can't stuff 6 people into a single bed motel room. Everybody needs their own bed. Likely it's only 2 people per room, and you would need 2 beds in there, that type of thing. So rates, as it says there, can vary I mean, $30 a day is pretty cheap. That's well out of a city. You'd likely be in a really small town, versus, you know, upwards of $200 a day where you're in a bigger city. Maybe it's, you know, like, you know, Kelowna or Kamloops or Prince George, where, you know, there's 100,000 people in the city. So the motel rates are higher. Again, it means calling around to the different motels and seeing what the rates are, checking their availabilities. And those rates, those daily rates, so those aren't work days. Those are days that your people are keeping the room. So if they work 6 days a week, you can't allow for a 6-day motel room rate in your estimate. You need to keep the room 7 days a week, right? So that is slightly different than what we've been doing all along. We've been renting equipment based on the number of days per week that we're working, whereas accommodation needs to be calendar weeks. So 7 calendar days per week. Meals. So of course your personnel need to eat. Typically 3 meals per day are provided. Meals can be managed in several ways. So if it's in a camp, the daily rate that you're paying for the camp includes meals. Typically it does. If you don't have a camp set up and you're putting your crew up in a motel, then you not only do you need to pay for their motel rooms, you also need to give them a daily allowance for food. So an example is, say it's $60 per day for food. It can vary. As it says there, anywhere $50 to $75 a day is a normal range. Again, it depends on where your crew is staying. If it's a smaller town, motel rooms are cheaper. Food is typically cheaper, so probably on the lower end of the scale. If your motel room rate is higher, you know, it's in the $100, $150 a day range or more, you want to be on the higher end for your food allowance as well. Again, the food allowance is not per work day, it's per calendar day. So if your crew is, again, if it's working 6 days a week, but your crew is in that town 7 days a week, so they get a day off, but they're still in that town, you still have to give them their daily meal allowance, even though they're not working. So MOBs and DEMOBs and flights. So how does your crew get home or to the project? Typically they fly or drive. Depends on the distance away from home. If it's only a couple hours drive, typically you would want your crew to drive there. You could pay them to drive there, pay them for fuel, that type of thing. Flights, again, you would need to pay for flights. So as it says there, what's reasonable? For example, asking someone to drive 16 hours to Kitimat may be impractical. So of course you wouldn't want to do that yourself. So asking your crew to do that is, nobody's going to do that. So you would need to fly them. So identify the cost of a typical return flight. So what that means is going on airline websites and just checking the rates. If you book, you know, well in advance, you can typically get a cheaper rate than, you know, trying to book a flight for the next day. You know, flying home on a Monday is typically cheaper than flying home on a Friday. So staying away from weekends is typically cheaper. If you can fly on weekdays, it'll be cheaper for you. That may not be practical for the project. Again, it's just looking at the different airlines websites to see what they charge. So as this second bullet here says, consider a percentage of last minute flights that you may need where full price is charged. So you're not going to get a discount if it's a last minute flight. So how long in advance can you plan your bookings? So photo on the left, a remote camp. Photo on the right is a small plane for northern flights. Doesn't have wheels, doesn't have a landing gear, it's got skis, so for landing on snow, snow-packed runways. So flights, so what you have to consider when you're determining costs for flights to include is how often will your people turn around, or how often will they need to fly home? So how many round trip flights do you need to allow for in your estimate? So you can add this cost in just so many flights at so many dollars per flight. That's one method. You can also calculate an hourly premium or a daily premium per person and allow for that in your estimate. So here's an example. So a $500 return flight once a month works out to approximately $2.50 per hour for that crew person based on a 50-hour work week. So 50 hours a week, so that's 200 hours per month that they're working. So 200 times 2.5 is $500. So you just, if you're going to use this method, you just need to know how many hours per week or per month, and then the number of flights per month that you're going to have that person come back. So whether it's one flight, two flights, etc., and then the cost of the flight. Okay, so that's flights to and from the town where your job is located close to. So the next one to look at is site transport. So you've flown your personnel up to the town or up to the camp location. So now how do they get to the actual job site from their, for example, from their motel room? So if we look at the camp scenario first, so you fly them up to the town and maybe they take a taxi to the camp. Does the camp provide transport to the job site? So maybe they have buses, for example. So typically that bus cost would be included in the camp price per day. So, or do you the contractor, the general contractor, provide your people with rental vehicles? That's a possibility. So pickups, or does the contractor hire a local taxi or bus? So there's different ways to do it. You can rent vehicles, up in the area. Maybe you ask if it's a long job, say it's 6 months long or longer, maybe you ask some of your employees to drive up company pickups to wherever this project is. You pay them to drive there. Then they leave the pickups there as the site vehicles, and you fly them home as they need to come home. So that could also be a possibility. So this service, so bringing people back and forth from the job site back to their accommodations, whether it's a camp or a motel, it may be required multiple times per day. So depending on the number of shifts that you're running. So if it's only one shift, it's just there and back each day. If you're working, you know, 2 shifts, then you're there and back each day. So just something else to keep in mind. So travel time. So depending on the company that you work for, possibly the employment terms for the workers may require reimbursement for travel time. So could include costs, so travel costs from their home to the job. So maybe it's an hour's drive from their accommodation to the project. So you would, if there's an agreement, you would pay them for that travel time. Another example here. So if you're flying your people from Vancouver to Kitimat, the example here says it's a 4-hour trip. So maybe it's you're at the airport. It's probably only an hour in this calculation, or maybe it's 2 hours, I guess. So 2 hours early, then it's a 1-hour flight, and then 1 hour from the airport in Kitimat to your motel or hotel. So that whole 4 hours, you may need to pay each employee for travel time. So the other example here is paying your people travel from their accommodations to the job, which I mentioned previously. So from the Kitimat hotel to the job site. Maybe it's a half-hour travel by rented bus or whatever it is. So travel time should also be thought of. Not every company pays travel time. You would likely have to pay this travel time. So the 4 or 5 hours of the getting to the airport, the waiting, the flight, you would likely have to pay for that. Possibly you may not pay for this. Again, it depends on your agreement with your employees. This is normally reimbursed at straight time. The travel time can be added to their hourly rate, or they're given a daily premium each day. They have a travel time premium. So labor costs. So typically workers are not interested in working out of town for a regular 40-hour work week. You would be hard pressed to find somebody that will leave their home and their family to work out of town for 40 hours a week. They want to work longer hours, more days to make more money. So they may expect 60 or more hours a week. So again, that will come down to your agreement with your employees. How many hours per week you include in your estimate will depend on the agreement with the employees. You as the estimator would be told that by management. You would be told, you know, use a 50-hour work week or use a 60-hour work week. So overtime premiums apply. So if it's a 60-hour work week, the hourly premium for labor is 16.6%. If it's a 70-hour work week, it's just over 20% premium. And if it's an 84-hour work week, it's a 25% premium. So those percentages are based on time and a half after 8 hours in a day, as well as time and a half after 40 hours in a week. Labor premiums may be an automatic calculation in software. So if you're using an estimating piece of software, it may do that calculation for you. you just may need to tell it how many hours a week you're working, and it'll come up with this percentage and apply that to your labor rates. The software that I use does that for me. I just tell it 1 shift a day times, 6 days a week at 10 hours a day. So that would be 60 hours. So it would apply this percentage premium to all of my labor rates. So labor, equipment premiums. So a couple things to consider. The duration of the project. So it may be more competitive to rent equipment locally to avoid the significantly higher MOB and DEMOB costs for short duration work. So if you need to move an excavator from your home base in Abbotsford, and you need to put it on a low bed and run it up to Dawson Creek, that's a significant cost. Thousands of dollars we're talking about per trip. So depending on the number of pieces of equipment you need, it may be more cost effective to see if you can rent something locally. So rent a similar sized machine and just have local MOBs and DEMOBs. So the next one here, hourly rent, or not only hourly, but rental rates in Vancouver, so the Lower Mainland, are considerably different than northern locations, meaning cheaper. So our rental costs down here are typically quite a bit lower than the costs that you'll see in, for example, northern BC or northern locations generally. So for a northern location, your equipment rates may need to be adjusted if the working window is weather dependent. So you will have to, depending on how far north the project is, you may have to analyze, does the work go over the winter period? Are you starting in the summer? So you work through the summer, you get into the fall, but then when winter hits, you have to stop and you can't work because it's too cold. That's possible. And you may have to come back in the spring. Whoops. Where did I get to? This one. So what's this example here? So if a machine can only work or excavate 10 months a year instead of 12 months, then your rental rate, you might need to adjust that rental rate to reflect this. So you may have to bump your ownership cost up some amount to account for this. So for remote sites, time lost traveling ice roads and sitting on site before and after the project. So if you're bringing equipment in from out of town, you may not be able to travel the off-road access route during certain times of the year or even certain times of the day. Thinking about cold climates, if it freezes overnight and then things thaw during the day, that off-road access may turn to such mucky quagmire that you cannot get a low bed up at during the day because it's thawed. You may have to bring the truck in, at night when things are frozen. That type of example. So if the low bed arrives at 2 in the afternoon at the job or at the start of the off-road portion, the truck driver may need to wait there till, for example, midnight until the road's frozen so that the driver can then carry on and get to the project site. So those number of hours that he or she is just sitting there, you're still paying for that. He's just not driving. So that type of cost is also should be thought of at least. You may not need to allow for it, but you should think about it, depending on how far north you go. So keeping up with equipment premiums, so downtime is expensive. So you're still paying for the machine, even though it's broken down. So if you've rented an excavator, for example, or maybe you've rented a whole fleet of equipment. Maybe you've got 3 excavators, a grader, 2 dozers, and you've got 5 dump trucks that you've rented. So when things start to break down, so for example, maybe the excavator breaks, and it's down for a day and a half. Well, maybe that's your only machine that can load trucks. So not only is the excavator broken down, but the trucks are useless as well. So you may or may not want to let the trucks go. If you tell the trucks to go home, they may find another place to work, and you may not get them back. So it's something to consider, downtime. Consider the cost of a site mechanic and or a shop. So determining what your needs are. If you've got a lot of equipment, maybe you need to hire a full-time mechanic and have them up on your job site full-time. You don't want to, per my previous example, if your excavator broke down, it's a simple fix, but you can't get a mechanic for 2 days. Well, you're still down for 2 days, even though it's an easy fix. So possibly the full-time cost of a mechanic is less than those potential downtimes of your crew. So you need to look at both sides of the coin and determine which one you want to take the risk on. So the next one here, do you purchase additional spare parts to maintain some type of inventory of parts up at the job site? So a mechanic can be in this range, plus their equipment and transport, accommodation, etc. So again, there's a real cost to a mechanic if you're employing them full time. So a site shop, so what that could be is maybe the mechanic has their own service vehicle. So it's got all of his or hers tools and fluids and everything on the truck. Maybe you need to provide some type of shelter for them to work in. Having a mechanic work underneath an excavator in minus 35-degree weather for 6 hours is probably not very realistic. You would need to provide some type of shelter so that work could be done. Again, it depends on how far north you're going, what the climate's like. Are there mechanics close by that you could hire when and if needed? Or do you need to bring your own mechanic? So photo on the left, so here's a service truck. So he's got all of his tools in here, and he's got fluids, oils, and hydraulic fluid, and antifreeze, that type of stuff. Lots of these heavy equipment service vehicles will have some type of crane on the back. This is a fairly significant one. So for removing this wheel and reinstalling the wheel on the loader, typically labor can't move around a large wheel like this or tire. You need heavy equipment to move this stuff around. Here's a relatively fancy shelter. So you've got 2 ship containers on either side, and then you've got like a sprung structure over top. It doesn't have to be overly fancy. Maybe you can hoard in the end so the wind doesn't just blow right through it. You can have a rental propane heater, right, that the mechanic can fire up when he gets cold, or she. The benefit of a setup like this is you've got these two containers that you can store tools and equipment and extra parts in. So there's a benefit there. So MOB and DEMOBs. So we've discussed labor, so getting personnel to and from site. So equipment, again, we've kind of touched on that. You can either truck it in or fly it in from your home base, or you can rent locally. So a material premium. So we've talked labor and equipment. So the third one there is a material premium. So you may have a material premium to truck your materials to the remote locations. So back many years ago, when I first started estimating, just as a side story, I worked for a company that had offices in BC and Alberta, and we did a lot of utilities. So the Alberta branch got a good discount on pipe from the Alberta suppliers. So what the BC branch did, which is where I was, we would get pipe delivered from Alberta, and it would be cheaper than even delivering it from Alberta, so trucking it from Calgary to the Vancouver area. So it was cheaper to truck it from one province to the next rather than purchasing it locally. That's not always the case. Likely for the most part, it's probably not the case anymore. As I say, that was quite a few years ago. So material premiums may only cover to a nearby city, so it may not bring the material right to the job site. Yes, you are, Andy. You do have to pay the PST. So even paying the PST, it was still cheaper to buy out of Calgary and have it shipped here. So I'm not sure if that was just a single anomaly or if the company I worked for, if they did that a lot. I was only there for a couple of years, so I'm not too familiar. So the quote will tell you, will confirm exactly where the material is being shipped to, whether it's the local town or it's directly to the job site. Andy, further to your question, if you decide not to remit your PST, you can be audited, and being audited by either the provincial government or CRA is not an exciting experience. So I would not cheat on that if I were any of you. So here's a ice road access photo on the left. So again, as long as the road's frozen, trucks can travel that ice road. Now this is fairly far up north. It really depends on where you're estimating the project. Air transport, maybe you need to fly equipment around. So some other material premiums. So the additional delivered distance. So you need to tell your supplier where they need to deliver the materials so that they can quote it accurately. Another option is producing on site. So things like aggregates or concrete or asphalt. if you're estimating a road project, you know, well outside of your hometown, or you know, way up north or something like that, far away from a local supplier of aggregates, maybe you bring up your own screening and crushing plant, and you produce your own aggregates out of a local gravel pit. That's a possibility. I've done that in the past. Actually, locally, I've done that for a project in Abbotsford. It was a Ministry of Transportation, so BC government project. It was a highway job. And if you, the contractor, wanted to, you could bring your own plant into the ministry's gravel pit and produce your own gravel at a cheaper dollars per ton than the local gravel suppliers would provide it for. So there's an advantage there if your company is capable of doing that. Same thing with concrete. So another job that I worked on while I was working near, I guess I should say, was the water treatment plant in North Vancouver, the Seymour water treatment filtration plant. My company did the earthworks there. So the next company that came in that was doing all the concrete work, they set up a concrete batch plant just a couple kilometers up the road in a gravel pit, and produced their own concrete and trucked it a couple kilometers to the job site, rather than having to drive concrete trucks, you know, 45 minutes or an hour each way in and out of town. The same thing could be done with asphalt. So really depends on the size of the project and what your capabilities are as far as your company. Can you do those things yourself, or do you hire the ready mix company to mobilize a mobile batch plant and produce concrete locally for you? All of those things are possible. So direct handling, delivering from a center. So again, that's truck deliveries. So as long as you're clear with your supplier, so maybe it's your pipe supplier, exactly where the project site is. So you give them a picture on a map so they can determine how far it is, you know, how many kilometers away they need to drive. Then they can give you an accurate delivery price for their materials. So storage of materials on site. So do you need to provide an enclosed space for your materials? So things like pipe can typically be stored outside. Not all pipe can be stored out in the sun for long periods of time. PVC pipe will degrade. Things like ductile iron pipe or steel pipe could be stored outside. Possibly if you're installing a water system, like a water main, the valves and things can be stored outside. Things with small parts or electrical parts is a good example, cannot be stored outside, hopefully for obvious reasons. They can't get wet. They can't have dust blown into all of their circuit boards and all that sort of thing. So you may need to provide some type of on-site storage facility. So again, it could be something like rented 20-foot ship containers. So maybe you have, you know, 4 of those brought to the site, and you install them such that you can have a forklift run in and out of them to store things in, or maybe the parts aren't that heavy. You can have, you know, labor pick the materials up and bring them into the containers. So materials in stockpile, so you may have additional handling costs. So a photo on the left is another example of a site storage. So again, there's your multiple ship containers with some type of roof constructed. So you have a shelter here out of the wind, out of the rain, and then locked containers for your goods. Photo on the right here is a crushing operation. So they're producing gravel. So of course there's a certain specification for gravels, depending on the type of gravel and what it's being used for. You do still have to meet the contract specifications, even if you're producing your own gravel. The specifications for the gravels will not change, whether you're producing the gravel or you're purchasing the gravel from a gravel supplier. So reason I bring that up is if you bring your own crushing screening plant up, you need to have somebody that knows what they're doing to operate it. It's not just turn it on and start loading gravel into it. There's all sorts of different sizes of sieves that you need. It depends on the material that you're feeding in, what type of material you can produce. Are you simply screening, or are you crushing larger rock into smaller rock to get fractured rock? Some types of gravel require crushed rock, like a road base needs to be crushed. You can't have round rock as a road base. So producing gravel, it's a specialty. Not anybody can do it. So then we get to things like your fuel premium. So most field equipment runs on diesel or gas. So you can develop a cost-effective method to deliver it. So think of different ways of how you're going to fuel your equipment. So some possible methods are listed here. So if you only have a small number of pieces of equipment, do you have a designated person with a tidy tank, as they're called, in the back of their pickup? Do they drive into town, fill it with diesel or gas or whatever you need, and then drive back to the job site and fill the equipment? Likely that has to be done daily. So it's not like filling your car up where you fill it up and then you drive for a week and a half and then, oh, you got to fill your car up again. Depending on how much you work your excavators and your dozers, you may need to fill them up daily. And they can be, an excavator can hold 200 liters quite easily. So like I say, it depends on the number of pieces of equipment you have and the number of pickups with tidy tanks you have. This is an option though. So another option is daily delivery by bulk carrier. So the big fuel trucks, they come to your job site and they fuel your equipment up. That's a very good option. All you have to do is call them and they'll show up that night or the next morning and fuel everything up. If that's available, that's a very good option. Or there's another type of bulk delivery where you have an on-site fuel tank. So maybe you have a bulk delivery, once a week, where this large tank is filled once a week. And then out of this tank that's on your job site, you run all of your equipment over to this site tank and you fill out of this tank all of your equipment. So again, there's costs for renting this tank, doing that type of thing. So fuel is more than likely a premium. So you're probably going to pay more per liter out of town than you are in the lower mainland here. And again, it's simply calling around. It's asking if there's bulk carriers in the area, what they charge. So you can make that adjustment in your estimate. So if you're going to do a site storage operation like this, what's shown in this photo would definitely not be allowed. So you see this it looks like probably a 10,000 liter tank, maybe more. It's kind of hard to tell the scale. It's got no containment around it. So you need to have a containment berm that'll hold 100 and I believe it's 110% of the volume of the tank. So that if it was completely filled and the bottom ruptured somehow, all of the fuel would be contained in the containment area. It wouldn't come out of there and start flowing downhill, you know, towards a creek or something. So if you're going to do this option, there's other costs than just renting the tank. You need to build the, as it says here, the enviro and the safety conditions into your site tank system. So general conditions, so things like climate, security, health and safety, environmental. So climate, is the weather so cold you need to allow for lunch breaks in heated lunchrooms? If so, this of course impacts productivity. The colder people are, the slower they work. Containment berm, yes, typically you can't use earth. So if you think about gas, it's going to soak into the dirt. Yeah, you need to have some type of liner so that the gas or the diesel won't leach into the ground. So climate, so weather, so what are the average working temperatures that the crews will be working in? As I say, the colder, the slower the crew works. Plus you need to provide things like a heated lunchroom. Typically, if it's that cold, the crew isn't going to stop their excavator or their dozer and jump out and have their lunch. They want to go back to somewhere warm where they can eat their lunch. So again, it's time from when they stop being productive, so stop their excavating or stop their dozing, and then it's them maybe getting back in their site vehicle and driving back to the lunchroom. So you're paying them to eat lunch, but you're also paying them to drive back and forth from their equipment. So again, that relates to lower productivities. Another thing to think of is, do you need to run your equipment 24 hours a day? So this was a scenario that I encountered. I moved to, so that same company that I was talking about that had the 2 different branches, I went to the Calgary branch and I moved there in, I think it was February. So it's still the dead of winter and we're a couple hours out of Calgary. So I went to the job site and was looking at the earthworks job that we were building. And at the end of the shift at 5 o'clock, everybody got out of their machines but left them running. So we had I believe we had 2 dozers, we had 4 articulated rock trucks, and 3 scrapers. So all the machines were left running overnight because it got so cold that the equipment would not start in the morning. So if that's a requirement, somebody's going to tell you that, so that you need to allow for more fuel being used, right? You're obviously burning more gas if you're running equipment 24 hours a day. So as I said, productions can alter dramatically depending on the weather. Security. So of course, if you think about it, if you're leaving equipment running while you're not there, you need to have security. So pretty good security. You don't want somebody that's going to fall asleep so that half of your equipment is gone the next morning. So that's definitely a cost if you're leaving equipment running. Health and safety. Again, depending on how far you are isolated from location, so how far away you are from a hospital, you may need certain equipment according to the WCB, so Workers' Compensation Board. So an ETV, so an emergency transport vehicle with a field first aid room. Depending on the number of people in your crew, you may need a higher first aid level. So, you know, maybe a level 1 doesn't cut it. Maybe you need level 2, level 3, etc. And of course, it costs more to put a person through that course. So the higher the level of first aid that they have, the more money it costs to put them through those courses. So environmental. So you may need additional environmental controls in sensitive work locations. If you're working, you know, next to a creek, you know, that type of thing. Doesn't have to be remote. I mean, you could be working in a sensitive environmental location in the middle of the city. That's possible. Overheads, so people like supervision. So you may have a supervision premium. So cross shifting, are you running multiple shifts? So of course, if you're running, say, 2 shifts per day, so you got a morning shift and an evening shift, you can't have the same supervisor supervising both shifts. This person can't be up 24 hours a day. So you may need 2 supervisors. So that comes into the second bullet here. So additional personnel when cross shifting. So the site office, cost of remote communication. So back in the day, before there were cell phones, and you needed to, the site office needed to communicate with the head office. Well, the people in the site office needed to drive into town and use a payphone. Or possibly the general contractor owned a satellite phone. Not like today where basically every person on the planet owns a cell phone. So that has changed. Getting power to your site office, so there's a cost to that. Is power available? Are you anywhere near the BC Hydro grid? Or is it not a possibility? Do you have to run generators? Washroom facilities. So allowances for management visits. So the crew needs to be flown out every, you know, whatever your agreement is, every 3 weeks. How often does management need to come and take a look at the site? Is it once a month, once every 2 months? Again, your management will determine that for you. They'll tell you, you know, allow for a flight for me once a month, kind of thing. So the productivity premium. So consider closely the potential adjustments in productivity for out-of-town work. So productivity can be impacted by the following. So being isolated from management. So if the crew is used to seeing a manager on their job site every day or every second day, they will be more productive as compared to having management show up once a month. Even though the supervisor's there every day, productivity will go down. Now, how much it goes down is, I mean, basically anybody's guess, whether it's, you know, 2%, 5%, 10%, you know, it's some amount. Next one here, so unknown local conditions. So including things like business support and ground conditions. So is the ground conditions significantly different than what you're used to? Is it harder? Is it more dense? Is there way more rock? Is the groundwater, you know, much higher than what you're used to? Does local business not support outside contractors? That's possible. You can be seen as being, you know, the people from the big city coming into the small town and taking away local people's employment. So that's a definite consideration. So how does that affect you? Well, an example is you bust a hose on your excavator. So you need a new hose. So you need the mechanic to come out from town and replace your hose. Well, maybe the local business, so the mechanic, isn't overly excited about helping outside contractors. Maybe they want to help all their local people first, and they'll get to you in 3 days when they're finished helping everybody else. So it's hard to analyze that, but it's just something to keep in mind. Climate, so we've talked about that. The crew behavior can change from social changes. So the crew, let's say they're used to living in, you know, the lower mainland where there's, you know, 100 different things to do after work, versus the small town where once you get home from work and you shower, you get cleaned up, you go have dinner, then there's nothing else to do. So typically what happens is people like to go to the bar. So the longer people are at the bar, you know, drinking, the worse their productivity is the next day. So again, it affects productivity. So equipment repair can be challenging. Again, availability of people, so the mechanic, availability of parts. Material delivery can be challenging. So here locally in the lower mainland, you call up your gravel supplier on Monday afternoon and say you need 4 truck and transfers of road base tomorrow morning on the job site. They say, yeah, no problem, they'll be there. Versus maybe out of town, you call the local gravel pit and you say you need 4 truck and transfers of road base. And they say, well, we've only got 1 truck, it's a tandem, and it's busy tomorrow. So you got to wait till the next day, and you're only going to get 14 tons at a time instead of 40 tons. So things like that drastically change your productivity. Maybe in the lower mainland, you think you can place 50 cubic meters an hour of road base with your little dozer. But if you can't get it to the job site that quickly, then maybe you're down to 10 cubic meters an hour. Simply because the material can't get to the job site quick enough. So those are things that you could ask, for example, the gravel supplier. You can ask them, how many trucks a day can you get me, you know, get to the site of the different materials that you need? And I mean, it's really going to vary depending on the specific gravel supplier that you're talking to. So the last couple pages are kind of like an estimating summary of kind of the bigger topics that we've gone over in this course. So things to keep in mind. So review the scope of work. So read everything. Read every page in the specs. Look at every drawing. Make sure you've read and you have all of the addendums, right? Confirm, do you have all 3 addendums or have you only seen one of them, right? Addendums change the specs. So they may delete things, they may add things, they may revise things. So making sure you have all of the addendums is important. Those are typically issued by the engineer, the design consultant. Ask questions for clarification. So during the bidding process or the estimating process, if things aren't clear to you in the drawings or the specs, Maybe there's something missing. Maybe a drawing conflicts with a spec, or drawing structural conflicts with the civil drawings. If you have any questions, ask the engineer, ask those questions, get clarification. That's also what addendums are for, is for answering questions. So break down the activities based on the bid form. So we've looked at a couple of sample bid forms. So set up your estimate based on those bid form, on those bid items, based on the bid form. If you have a bid item for road base and a bid item for sub base, you need to price those separately. So come up with a unit price for road base, come up with a separate unit price for sub base. You can't combine the two together. So you have to bid on what the bid form is telling you to bid. So each individual item needs to be bid separately. Perform accurate quantity takeoffs. So in a unit price contract, so you're given quantities. So you're given, you know, so many thousand cubic meters of road base, so many lineal meters of 300 diameter storm main. So you still need to confirm those quantities. Check the drawings, come up with your own quantities, see if your calculated quantities match the bid quantities. They should be close. So further break down the activities as required. So what that means is that's your work breakdown structure. So inside the maybe the utility item, so the 300 millimeter storm main item. So that'll be a single line item in the tender form, you know, 1,000 meters of 300 millimeter storm pipe. But inside that bid item, you're going to break it down into things like, you know, survey layout, things, you know, that we practiced earlier in this course. You got layout, you've got trenching, so you come up with volumes. You've got your placing of your bedding and compacting. You've got time for your crew to set the pipe. Then you place the rest of your backfill. And then you do whatever's needed on the surface of the trench. So all of those things can be sub items in your tender item. So maybe you've got 5 sub items inside that one bid item. Estimate productions. So for now, because you're all just getting into estimating, productions would typically be given to you by your more senior colleagues. So maybe your manager, maybe there's a chief estimator that you're going to be working under. They can give you your, you know, the lineal meters per hour of pipe installation, depending on pipe size, pipe depth, existing utilities in the ground. How fast you can place your embankment fill to build up that 4-meter high embankment for your bridge approaches. So those types of things will likely be provided to you that hopefully you'll learn as you're going, and you'll retain that information for future estimates. On a side note, before I get onto this next bullet here, if you are hired by a contractor as an estimator, and you are sent out to the field, meaning you're not in the office estimating, don't take that as oh, you're being shuffled off somewhere because you don't know anything. So the purpose for doing that is so that you can learn what crews look like. So what the pipe crew is, how many people are on that pipe crew, what do they do? What are the different pieces of equipment that are typically used with your company in that pipe installation? You can see how many pipe per hour are put in the ground based on the depth of pipe and the size of pipe, etc. So if you're sent to a job site, you're learning things like how to build crews. So what's in a pipe crew? What's in an earthworks crew? You're also learning firsthand productivities of those different procedures. That's what I did when I first started estimating. Was I was on the job sites, learning productivities, learning crews. You can be told those things. You could be handed a piece of paper and that says, you know, a pipe crew has 2 excavators, you know, a grademan, 2 laborers, a compactor, and a 580, and 3 dump trucks. You can be told those things, but I think you retain it better if you see it happening. You see all those different parts and pieces working together to build the project. So add costs. So you've got your quantities, you've got production, so you know how many hours that you're going to allot to each quantity. So then you need to build your crews, right? Labor and equipment. You purchase all of your materials that you need based on the quantities that you had up here. Remember to include PST. So add things like subs. So maybe you're bidding a road project. Maybe you're twinning a highway, so you're adding an extra 2 lanes to a highway. Maybe your general contractor that you work for can do all the earthworks, can do all the gravels. Maybe you need a subcontractor to pave and a subcontractor to line paint. So you add in your subs. The next one there is general conditions. So those previous bullets that we just looked at are all direct costs. So you've got direct labor, equipment, material, sub costs. So then you get to your general conditions. So look back at our general condition class from a couple of weeks ago. So what things do you need for general conditions? Things like site office, superintendent, maybe bonds and insurance, quality control, traffic management, environmental costs. So those things are your general conditions, MOB and DEMOB. So next thing to look at is project schedule. So based on your estimate and the productivities, so you can maybe with a little bit of help from some senior people at your company where you work, you can produce a rough schedule on how long it's going to take to construct that project. So compare that rough schedule to the schedule that is required in the tender documents. So maybe your rough schedule says it's going to take 4 months to build this job, but the tender documents say it must be completed in 3 months. So you need to add crews to build the job quicker. Sometimes there's a premium for that. Maybe you don't have extra crews. Maybe you need to hire more people. Maybe you need to hire a sub that can help you install pipe. So there would be a premium for that. Maybe you need to add more equipment so that you can do things quicker. Maybe that pipe crew with 1 excavator, maybe you need to rent a 2nd excavator so that it allows you to install pipe quicker. So some examples. So add costs for, so I mentioned those in general conditions. So overheads, so things like insurance, bonds. Include your profit. So is it a percentage markup that your manager wants you to add, or is it simply a dollar amount? Is it, you know, $100,000 that you're to add to your estimate? So once you've kind of added all those things up and written them down, typically you're using some type of software to do this, so it's easy to make changes printed out. So then you review with management. You go through the estimate. So typically the manager will know overall what the project is. You may need to provide details to them. They may know that you're installing, 200 millimeter ductile iron water main that's 250 meters long. You may need to tell them that the tie-ins are 3.5 meters deep. They may not know that. Or things like there's a section of the job where the water main needs to go under 12 different utilities. So there's a huge productivity impact when you're going under utilities, existing utilities. So you would bring up things that the manager does not know about that specific job. So they likely haven't gone through the drawings in detail as much as you have. So once your manager is satisfied with your estimate and you've come up with your profit, so then you fill out your tender package. So you write in your unit prices, you extend those unit prices to the totals, which is what we did last week's assignment, right? That spreadsheet. You get your corporate signatures. So typically it's the owner of the company signs the tender document, and typically a seal is applied. You make sure you have your bid bond if the tender documents require it. So then you put all that in an envelope, you address it correctly, and you submit your tender prior to the close date and time. So if the tender closes Thursday at 2 p.m., you need to literally hand your envelope into the person that's there to receive it before 2 p.m. So 1:59 is fine, but the tick of 2 p.m., they will not take your envelope. So you've spent that 2 weeks doing that estimate for nothing. So estimating, it's a methodical, thorough, accurate approach that yields the best estimate. I can't stress enough to be organized, neat, tidy. You need to be able to read what you write or print. Other people also need to be able to read and write or read what you've written. Maybe your thought process on how you thought things would be done. Maybe you need to provide some notes at certain parts of the estimate to explain your thoughts. That helps. I do that every estimate that I do. It helps with your bid reviews. It reminds you as well as the estimator what you were thinking at that time when you were filling out that part of the estimate. Okay, any questions on the PowerPoint? Okay, so it's 10 after 8. Let's take a 10-minute break. I need to refill my glass of water. We will go over, there's an in-class lesson or exercise, I guess, if you want to call it that. So that's lesson 9 that we'll go over. That includes things that we just looked at in the PowerPoint. And then after that, we will quickly review the exercise 8 that you should have already submitted from last week. So that won't take long, maybe 5 minutes. And then right at the end of class, I will talk briefly about the final exam, some things that you can expect on the final. So it's 8:10 according to my computer. So let's come back at 8:20 and we will finish off. So I'll pause the video recording as well. Continue recording. So today's lesson looking at out of town premiums. So I'm going to share my screen here. So we'll go over some calculations of the different things that we looked at in today's PowerPoint presentation. So this Word document that you see here, I posted it to the Learning Hub newsfeed, complete with the solutions. Because this isn't for marks, I gave you the handout with the solution on it. So this may help you with your exam next week. So if we read it here, zoom in a little closer. So you are estimating a civil project located about half an hour from Kitimat. The project duration is 12 weeks. So based on 6-day per week, 12-hour per day work time. So the crew will go, they'll turn around every three weeks. So meaning every 3 weeks, you will fly them home to visit their family. So the crew is entitled to 1 hour of travel time at straight time each day. So question 1, what's the hourly labor premium in percentage? So first thing we need to do is determine how many total paid hours each week. So we have 40 hours at straight time. That's what the 1x means. So we've got 6 hours again at straight time. So that's your travel. That is 1 hour of travel time at straight time each day. So that's what this is. 6 hours at straight time here. So then the 32 hours at time and a half. So 32 plus 40, right? That's 72 hours. So 6 times 12, that's 72 hours. So all I did there was the first 40 hours of straight time. So go the calculated total 72 hours minus the straight time hours leaves you with the time and a half hours. So we add all those up. So 40 plus 6 plus 32 times 1.5 is 94 paid hours. So 94 paid hours divided by 72 hours of working hours equals 1.305 premium, or 30.5% premium. So that's your labor premium percentage. So 32 hours, where does that come from? So if we first look at how many hours per week the crew is working. So the crew will work 6 days per week, 12 hours per day. So 6 times 12 is the total hours per week that they will work. So 6 times 12 is 72. 72 hours per week. So we know from our earlier class, earlier in the course, that up to 40 hours a week is straight time. So up to and including 40 hours. So I first take 40 hours at straight time. So what essentially I've done is, out of that 72 hours, 40 is straight time. So 72 minus 40 leaves 32 hours at overtime rate. Okay. So the premium percentage is 30.5%. So the next question, what is the hourly premium for a laborer that costs $45 an hour? So how would you apply this premium to this labor cost? This part there we go. So simply the 45 an hour times this premium rate that we calculated, so times 1.305 equals $58.73 per hour. So that includes the overtime cost. So, okay, so next question. A flight costs $600 round trip. So what's the hourly premium for each member of the crew? So we know the crew will be flown home every 3 weeks. So first thing we need to do is calculate the number of flights that each person will get. So 12-week project, every 3 weeks we'll return home. So 12 divided by 3, so 4 round trip flights. Thinking about this should actually be 5. Anybody have any idea why that is? So when you first send the crew, right, so you need to count for the flight up to begin with and the flight home. So the flight up is your first flight. So 3 weeks later is your second flight. So now you're 3 weeks into the job. So 3 weeks later is your third flight. So now you're 6 weeks into the job. 3 weeks later is your fourth flight. So you're 9 weeks into the job. And then again, 3 weeks later is your last flight. And so that's your fifth one. So there's 12 divided by 3 is 4, but you need to add 1 for the ends of the 12 weeks. So let's make that little adjustment here on the solution. So we'll say not 4 flights, we'll say 5 flights times 600 is $3,000. So what are the total hours worked? So 72 is the 72 hours a week and 12 weeks. So 72 times 12 is 864 total hours worked per each person. So the last thing we do is take the total flight cost, so 5 times 600, which is 3,000. Divide that by the total hours worked per person. Remember, this calculation here is the total flight cost for one person. So 3,000 divided by 864. Let's change this. 3,864 divide. So that is $3.47. So that would be your hourly premium that you would want to add to each person for their flights. So you've got this based on overtime and their travel time. You would then add this amount to that to account for flights. It's round trip, $600 round trip. It's probably low, but that's the number that's in this example. Yeah, I guess now that you mention that, so your initial flight there, your initial $600, so that's a round trip cost. So that flies you there at the start of week 1, and it flies you home after 3 weeks. Yeah, I think you're right, you. It is 4. I'm going to change this back there and delete this. Good catch. So it is 4 flights at $600, which is $2,400. Total hours worked doesn't change. And so your premium per hour then is the $278. Right. Okay. So that's your flight hourly premium that you would add to this other number up here. So the next question, number 4, accommodations cost $1,500 a month. Food is $60 a day. So what is the daily rate? What is the hourly premium? So let's look at accommodations here. So $1,500 a month. So $1,500 a month divided by, we're saying there's average 30 days in a month. So 1,500 divided by 30. So that's $50 a day for accommodations, plus the 60 a day, whoops, for the food. So totals $110 per day for food and accommodations based on 7 days a week. So make sure we remember this. So that's 7 calendar days per week, right? That we need to allow for $110 per day. So the hourly premium is our 110 a day that we just calculated. So times 7 days. So that gives us the total premium for a calendar week, right? $110 times 7 days. Then we need to divide that by the hours worked per week. So you would do 110 times 7 would be 770, divided by 72 worked hours per week would give you a premium of $10.70 per hour for accommodations and food. Again, if you wanted to, you could add all these together into your labor cost. So think of how much we've added there. So we've got some overtime cost here, which I guess you could have that in if you were working out of your home base as well, if you wanted to work longer hours and more days a week. But if you forgot this part, so questions 3 and 4, if you forgot these in your estimate, you would be short, say, $2.80 an hour plus another $10.70. So what's that? $2.80 and $10.70. So you'd be short $13.50 per work hour per crew member. So 864 hours, that's about $11,700 per person. So depending on the number of people that you're sending up to this job site, if you forget to add these costs, it's a big number. Okay, question 5. The project only has 1 excavator for equipment that it needs. So hiring a local mechanic appears to be the least expensive method to perform the servicing that's required on the excavator. So every 250 hours, the machine needs to be serviced. 250 work hours. So the call out rate for the mechanic is $125 per hour. The minimum call out is 4 hours. So you're going to pay that mechanic 4 hours times $125, regardless if he's there for 20 minutes or 3 hours and 45 minutes. You're still paying him the same amount. If you go over 4 hours, then it's $125 for each hour after that. So what is the anticipated project premium for the mechanical servicing? So again, from previous calculation, so 72 hours per week times 12 weeks. So a total of 864 hours worked. So that excavator will be operating for 864 hours for the project. Correct you. So you go total number of hours divided by the servicing interval, which is 250. So it would need 3.5 services. In this case, we could round down. So it needs 3 services out of town. Whoops. So 3 services times $125 an hour times 4 hours. So that's $1,500. So the last question here. The site is located far enough from town that daily fuel delivery is not an option. The fuel price, so the dollars per liter, is competitive. However, there's still a premium to our regular at-home rate. So there's still a 10-cent per liter premium that we're going to be paying than we're used to paying. So in addition, you will need a diesel tank, so an on-site tank, that costs $5,000 a month to rent, plus $600 delivery each way, so 600 times 2. So what's the anticipated overall fuel premium, assuming the excavator is burning 30 liters per hour? So those are MOB charge, so that's simply $600 times 2 ways, so $1,200. So the rental, so we said we're up there for 12 weeks, so that's 3 months, right? 12 divided by 4 is 3 months. So 3 months times 5,000 a month. So there's our rental bill, 15 grand. The fuel that we'll need, so we have 864 working hours. So the machine will be running that long. It consumes 30 liters per hour. So that, multiply those two together to see how many total liters we'll burn through. So times the premium. So we said we had a 10-cent premium over and above what we're used to paying for fuel. So that is, so multiply all those 3 together, and that's $2,592. So then you would simply add those up. So 1,200 plus 15,000 plus 2,592. So our fuel premium, so over and above what we would normally pay in our home base area, is almost $19,000 for one excavator, just in fuel. So that's the end of the in-class lesson. Any questions on what we went through there? So like I say, I posted this Word document to the Learning Hub. MOB and DEMOB, that was here. Oh, of moving the machine up, you mean? Hey, you're right, that's not here, is it? We've got servicing, we've got fuel, We have crew accommodation, crew flights, and then the overtime premium. Yeah, we didn't mob our own machine up. So that should be in here somewhere. So we should have 2 ways times, you know, depending on the size of the machine, depends on how long it takes the low bed to get there and come back. You know, you might pay a lesser rate if the low bed is able to pick up somebody else's machine up in that area and bring it back down to, you know, kind of our home base area. So they almost have a 2-way haul. If the low bed's coming back empty, you're paying him per hour to drive up, and then you're paying him per hour to drive back down. So if the truck is able to find, you know, something else to pick up there and drive back, you would only have to pay him to go up there. He would charge the other company the cost for him to come back down to where you are. So that's, I mean, that's the ideal scenario where he's able to go to haul both ways. So he's not coming back empty. Okay, so that is exercise 9. So there's no marks for that. Assignment 8 is the last one that I marked. So I'll close that one. So the last thing we have to do is, or the second last, is review exercise 8. So we can do that relatively quickly here. So 8. Squeeze this down a little. So I think we did the first 2 last week when I went through it. So I haven't looked at your handed in assignments yet. I'm assuming everybody got this basically correct. I did the first 2 for you, so all you had to do was continue on with that process all the way down. I'll reiterate what I did to begin with. So you're given everything in black here. So you're given the quantities. You were given the labor, equipment, material, and sub costs here. So that's the total. Down here, you were given the overheads. So there's your overheads, there's the total. So the reason I did this calculation, so total overhead divided by total cost of estimate, 6%. That is how I prorated the amount of overhead that goes into each bid item. So you can do it either way. So what we did initially was we took this number here, this total cost for the line item, divided it by the total estimate cost, and then multiplied by this total amount. So that would give you the same number. So what's shown here in this Excel spreadsheet is, if I double click on it, it takes the total cost here for the line item and multiplies it by the 6% calculation, which is the ratio of overhead to total cost. So both of those methods should produce the same dollars, and I'll prove that here. So this divided by that, whoops. And then times that. Oh, I haven't shared that. Thank you. I haven't shared my spreadsheet. Here we go. Now can you see? Okay, so this is your week 8 exercise that I'm just going through. So everything in black was provided to you. Everything is red is what you've calculated. So you were given costs here, total cost for each line item. So the total of that column is here. Excuse me. You were also given overheads. So there's your total overhead. So as I said previously, before you could all see it, I went through these first 2 items here last week when I handed out this assignment. So basically all you're doing is the exact same calculations all the way down. So I won't go through each one because, like I say, it's a repetitive calculation. The only thing I will say is, well, I'll say 2 things. It's important to, at the bottom, once you've done all of your calculations and you get to the bottom and you're finished, to sum up your individual columns. So 15,286, that's my overhead. That number should match the overhead in our estimate down here. Similarly, yeah, you could total your profit to see what the total profit is. Once you add these 3 lines together, you get the total or the subtotal for each line item, right? So that is all these numbers. Simply adding those 3 columns together. You could total that column. So then you could check to make sure this number is correct by simply adding up those 3 subtotals as well. So the 3 of those together should equal that number. For your unit price on the end, all you're doing is simply taking your total number here and dividing it by the quantity. So the blue cell divided by the red cell. Andy, yes, that is the last thing that I want to mention here is the way that this is shown on my screen here is we've allocated overheads and profit to this provisional sum item, right? We've got $375 of overhead and we've got $795 of profit. Now, last week when we went through the PowerPoint, I mentioned that provisional sum items, so meaning this 100mm asphalt surface bid item, provisional sum items can be deleted at the owner's discretion, and you will not be compensated for it. So what that means is this overhead, this amount of overhead that you've inserted into this line item, right, that's included in our submitted unit price, if this provisional sum is deleted, so if the owner does not want to do the surface lift of asphalt, they can choose to delete this row. So that means we will not be paid a portion of our overhead costs. We're still going to spend $15,286 of overhead cost, but we're not going to get paid at all because this line item has been deleted, right? We're not going to get this 375. So what I do in my day job is I don't spread overheads. So when I say spread, that's what you're doing, this calculation. So you're taking this total overhead and you're spreading it over all your bid items based on the size of each individual bid item, right? This big one here, that's more than half the cost of your estimate, receives more than half of your overhead costs. So getting back to the provisional sum, if you spread your overhead on a provisional sum item, there's a chance you will not get paid that portion of your overheads. So I do not spread overheads onto provisional sum items. So I don't do this for sure. And this one you may or may not do. You may or may not put the 12% profit on it. Because if you don't put your overheads there and you spread them elsewhere up here, you'll still get paid your $375 based on doing all this other work, because that $375 will be buried in these other items. You could still apply the profit to this line item, this provisional sum line item, because if you go ahead and do the work, maybe this is a subcontractor, you want to make some money on that sub doing their sub work. So you would mark up, you could mark up the provisional sum. If you did not make any changes down here, I'm not going to mark you wrong in your assignment, your exercise. I threw this out there last week just to see if anybody would pick up on that. Looks like Andy did. So I mean that's basically how you spread your overheads. It depends on the ratio of how big the line item cost is compared to the overall estimate. So any questions on assignment 8? Okay, so that's assignment 8. So the last thing, I'm going to stop the recording, so I don't want me talking about the final exam to be on a recording.